An important aspect of the problem solving we'll do this year involves units and dimensional analysis, which is an analysis based on units. Units need to be defined. They are the increments of measurement, and these are the particular values by which we have conducted a measurement. So, for instance, 5.5 meters. Those meters would be the increments of measurement, and we would label that on the numbers in our calculations and formulas. It's important to distinguish between units and physical quantities. They're going to be represented by symbols usually, and sometimes the same symbol in one context will represent units on a number, and in another context will represent a physical quantity in a formula. Let me give some examples here. Physical quantities we're going to be measuring this year or calculating with are going to be things like displacement, mass, time, velocity, force, energy, and power, and here are their symbols. And we might compose formulas with those symbols to show how, force relates to mass. It relates to acceleration, which is not on here, but you have to have a formula with force, with an F for force in it and an M for mass in it. Well, when we measure mass, we're going to measure it in kilograms. When we measure displacement, we're going to measure it in meters. So these units over here, these are symbols actually for the increments of measurement that we've used to measure these physical properties, these physical quantities. So I want you to keep in mind that sometimes you'll be looking at a formula or an equation that has all symbols, and at other times you'll have plugged the numbers in, and the numbers will have little letters next to them which are symbols for the units in which numbers were measured. Here's an important point. If you plug numbers with standard units into a physics formula, you'll get an answer in standard units. If you want to get standard units out of a physics formula, you need to plug in numbers measured in standard units. I'd like to show you a little bit of what I was talking about here. This is the old end of course examination STAR physics reference material formula sheet. It shows us formulas or equations for various physical quantities. Here's the physical quantity velocity, and it's composed of displacement divided by time. We've used V, D, and T there as symbols for physical quantities, but if I were solving, I might want to know the velocity in terms of the number of meters divided by the number of seconds. So I would be putting unit symbols in instead of physical quantity symbols. So I just want you to keep these in place. Furthermore, sometimes we'll make up units that are powerful or meaningful out of other units. For instance, down here we see a Newton. That's the unit of force. Well, it's composed of kilograms multiplied by meters divided by seconds squared. So here's a unit that is a composition of other units, and it will probably match the formula. It does actually. Kilograms are units for mass, and meters per second squared are units for acceleration. So if you go back up, you'll see the formula for force is force equals mass times acceleration. So you can analyze what the units should be and how they should combine together to check yourself in your calculations. Alright, I'm going to propose a new unit here in a minute to talk about transport efficiency. In many large cities, their freeway systems will have what are called high occupancy vehicle lanes, and these are lanes that can only be used by vehicles that are carrying more than 2 people. This is to encourage people to carpool or be more efficient by carrying more people per vehicle. Other vehicles will have to stay in the situations where the lanes are crowded and the traffic is slower, but these high occupancy vehicle lanes will often be less congested, and so you give an advantage to people who were trying to be more efficient. That's the idea behind these high occupancy vehicle lanes. I've got a problem here for us to consider. It says let us consider which would use less fuel for transporting 7 people 20.87 miles from the suburbs to the downtown area, a Prius or a Chrysler Town and Country minivan. But before we do this, I'd like to propose a different unit just for you to be thinking about the efficiency of a vehicle. Because we're used to thinking of the efficiency, the fuel efficiency of a vehicle in terms of miles per gallon, or maybe in another country in terms of kilometers per liter. And that only considers how many miles will a vehicle go on a certain number of gallons. But I want to propose people miles per gallon as a unit to compare efficiency. What this does is takes into account how many people are riding in that same car getting that gas mileage. So if I run one person in a Prius alone, then the people miles per gallon will be 48 people miles per gallon. But if I fill it up to its maximum capacity with 5 people and they go down the road getting 48 miles per gallon, then we've got a much better efficiency, 240 people miles per gallon. Likewise, if I run a single person down the highway in a Chrysler Town and Country minivan, it will be getting 25 people miles per gallon. But if I fill it up with 7 people and it still gets 25 miles per gallon, which it can pretty well do, then we'll be getting 175 people miles per gallon. So just thought you might like to consider that. Might think about maybe the people miles per gallon efficiency of a big bus or something that gets terrible gas mileage with just the driver driving it, but loaded up it gets pretty good people miles per gallon. Okay, to calculate how many gallons of gas each scenario will require, we'll need to use the appropriate values that were given in the problem, and then we'll have to conduct the various math operations that are required to cancel all units except for gallons of gas. Also, we'll have to think critically about how the problem limits us in the way it's stated. Well, first of all, what are we trying to solve for here? We're trying to figure out which vehicle, either a Chrysler Town & Country or Toyota Prius, would use less fuel to transport 7 people 20.87 miles. So fuel, less fuel, that's number of gallons, right? We need to calculate the number of gallons. We know the number of miles, 20.87. We know the number of people, 7 people. And we have a number for gallons per person per mile. Now look, that might look funny. I was saying people miles per gallon. I was saying the inverse of this fraction, the inverse of these units previously, right? People miles per gallon. And down here we're seeing gallons per people mile. Why did I flip that? I flipped it because I must come out in gallons down here, so gallons have to be in the numerator, and that will help cancel people and miles out of the equation. So this is where dimensional analysis comes in. Well, you have to consider what's going on with the problem, though. There are limitations. For instance, the Chrysler Town & Country can take all 7 people in one fell swoop, one trip, and they'll all be delivered. The Prius is going to have to make multiple trips, right? They're going to take 5 people. The driver's going to have to come back and get the other 2. Okay, so we'll animate that. Prius dropped off the 4, picked up the 2, went back. So look, the Prius had to drive 3 times as many miles. Yes, it was getting better miles per gallon, but it had to drive 3 times as many miles. That's where you might start thinking about people miles per gallon. But we're not going to use people miles per gallon in this situation because we've already determined it's just a matter of figuring out how many gallons they've used. It's a matter of how many miles and how many gallons per mile. Now notice we're used to hearing miles per gallon, but I flipped the units again. I have to flip the number that's with them, right? I flipped the units because I'm trying to end up in gallons, and gallons need to be in the numerator, and miles need to cancel out. And by the way, the reason we don't have people in this calculation is because we took the people into account when we're figuring how to get them all there. So we've reduced the problem down to just miles and miles per gallon. Here are our calculations. We said the Chrysler Town & Country gets 25 miles per gallon. We said the Toyota Prius gets 48 miles per gallon. Again, those units and numbers are inverted so that the units will cancel out properly to give us just gallons. And notice, surprisingly, the Chrysler Town & Country minivan wins because we needed to transport 7 people. If we'd only needed to transport 5, of course, the Prius would have won. Or if it had been any number 5 or less, Prius would have won. Well, what have we learned today? What are the key points? One key point is that a number doesn't have meaning unless it has units. If I just say 3, you need to ask 3 what? 3 meters, 3 gallons, 3 kilograms. The unit is what gives the number meaning. Also, unit symbols should not be confused with the symbols that are used for physical quantities. For instance, kg is a unit symbol for kilograms, but m is the unit symbol for mass, and mass, the physical quantity, is measured in kilograms for units. Also, we're going to calculate in physics. We want to calculate using numbers with standard units. If we do that, we'll get answers that come out in standard units. That's the only way to get answers that come out in standard units. Either that or you're going to have to convert at the end. Also, we've shown that you can compose new units from combinations of other units to make useful comparisons, such as our people miles per gallon, but also we pointed out that newtons are units of force and they're combinations of other units. And then finally, one of the ways we can guide our setup for calculations is through dimensional analysis. If we set everything up so that all the units cancel out to the proper units for the answer, then we've probably done something right in our calculation.